Hello children, hope you're all keeping safe by staying at home. Today I'm going to begin the first chapter of Standard 10 Science, that is Chemical Reactions and Equations. Now before we begin this chapter, it is very important for us to know the basic difference between physical change and chemical change. The basic difference between physical change and chemical change is that in a physical change, no new substance is formed. Only physical properties like state, shape, size, color, etc. change. Whereas in a chemical change, always new substances with new properties are formed. So this is the basic difference. In a physical change, no new substance is formed, whereas in a chemical change, always a new substance or more than one new substance with new properties are formed. Now let us just see a few examples of physical change. Melting of ice. So here, no new substance is formed, only the state changes from solid to liquid. Boiling of water or milk, again here the state changes from liquid to gaseous state. Cutting of wood or paper, here there is only a change in shape and size, so no new substance is formed. Now a few examples of chemical change. Rusting of iron, a new substance is formed, a rust, which is a new substance. Hydrated ferric oxide, it is formed during rusting of iron. Curdling of milk, that is milk turns to curd, so again a new substance is formed. Burning of wood or paper, here again wood or paper turns to ash and a new substance is formed. Now let us come to chemical reaction. In simple terms, a chemical reaction is a chemical change. So a chemical change can also be called as a chemical reaction. So we can define chemical reaction as a process in which one or more substances, which are known as the reactants, are converted into different or new substances with new properties. And these new substances are called products. So in simple terms, we can say in a chemical reaction, the reactants convert to products, and the properties of products are different from the properties of reactants. So once again, chemical reaction is a process in which one or more substances are converted into different or new substances with different or new properties. So let us have a look at few examples. First example, zinc granules react with dilute sulfuric acid to form zinc sulfate, and a brisk effervescence of hydrogen gas is observed. So in this chemical reaction, the reactants are zinc granules and sulfuric acid, and the products are zinc sulfate and hydrogen gas. Now what is the meaning of brisk effervescence? Brisk means fast. Effervescence means tiny bubbles. So whenever a gas is evolved in a solution, it comes out in the form of tiny bubbles. So one example is when you open a bottle of Coca-Cola. As soon as you open, you see brisk effervescence. That is of carbon dioxide gas, not of hydrogen, right? Second example, magnesium ribbon burns in air with a bright, dazzling light to form a powdery white ash of magnesium oxide. Now here our reactants are magnesium and air or oxygen, and our product is magnesium oxide. So A chemical reaction is where one or more substances known as reactants are converted into new substances known as products, which will have new properties. There are thousands and thousands of chemical reactions going on around us every moment. So just imagine if we were to write chemical reactions in the form of sentences, how difficult it would be or how time consuming it would be. So here we are going to learn the short representation of a chemical reaction. How we can, instead of writing it in sentences, how we can write it in short. So there are two types of equations which can represent a chemical reaction. One is word equation and the other is chemical equation. Now, when you write an equation, you have to remember that the reactants are always written on the left hand side and the products are always written on the right hand side. An arrow pointing towards the products is placed between the reactants and products. Once again, the reactants are written on the left hand side, products on the right hand side. An arrow pointing towards the products is placed between the reactants and the products. Now in a word equation, we write the names of the reactants and products in the equation. Our first example was the reaction of zinc with sulfuric acid to give zinc sulfate and hydrogen. So it can be written in the form of a word equation by writing the name of the reactants, that is zinc plus sulfuric acid gives zinc sulfate plus hydrogen. Our second example was the burning of magnesium ribbon in air to give magnesium oxide. So it can be represented in the form of a word equation it can be written in the form of a word equation in this form: magnesium plus oxygen gives magnesium oxide. Now, chemical equation is the representation of a chemical reaction by using symbols and formulae. Word equation we had written by using names of the reactants and products. In chemical equation, we are going to represent the chemical reaction by using symbols and formulae of the reactants and products. So this word equation of the reaction of zinc with sulfuric acid can be written in the form of a chemical equation by writing the symbol of the reactant, that is zinc, Zn, plus formula of sulfuric acid, H2SO4, gives zinc sulfate is ZnSO4 plus hydrogen is H2. So Zn plus H2SO4 gives ZnSO4 plus H2. Similarly, the second example of burning of magnesium ribbon equation can be written by using the symbol of magnesium, that is Mg, plus oxygen is O2, gives magnesium oxide is MgO. So Mg plus O2 gives MgO. The arrow can be read as gives or yields. So Mg plus O2 gives MgO. Now you must be wondering, what is this 2? Why this 2 is written in front of Mg and again here a 2 is written in front of MgO? Well, those numbers are written to balance the equation. Balancing of a chemical equation we will be learning later. Now let us see how to identify a chemical reaction. How will you know whether a given reaction is a chemical reaction or a chemical change or not? So there are some characteristics which help us to identify a chemical reaction. First is evolution of a gas, and this can be observed as effervescence. When you see an effervescence, it means that the reaction is a chemical reaction. Formation of a precipitate. Precipitate is an insoluble substance, solid substance. So if you see the settling of insoluble solid particles in the reaction, then you know that it is a chemical reaction. Change in color. If you remember last year, we have done this activity where we put iron nails, iron filings into copper sulfate solution, and the color of copper sulfate solution, the blue color, changed to green due to the formation of ferrous sulfate. So that change in color also indicates a chemical reaction. Then change in temperature. If the reaction mixture becomes hot or it becomes cold, then you know that it is a chemical reaction. Change in state. Even when there is a change in state from solid to liquid or liquid to gas or vice versa, again then it is possible that a chemical change has taken place. So in a chemical reaction, you can see either one or more than one of these characteristics. A chemical equation can be made more informative by stating the physical state of the reactants and products, the heat changes occurring during the reaction, and conditions of the reaction. So let us learn how we will include these information in the chemical equation. So the physical state can be represented in the form of symbols. Solid can be represented as small s in bracket, liquid, small l in bracket, gas, small g in bracket or upward arrow. Aqueous solutions are solutions in water. They can be represented as AQ in bracket. Precipitate, as I told you, insoluble solid substances. It can be represented as small s or a downward arrow. Heat is represented as a small triangle. Next is the concentration of acids. Dilute acids are, or dilute is symbolized as DIL or AQ. Concentrated can be written as CONC. Next is heat changes occurring during a reaction. If heat is absorbed during a reaction, it is known as an endothermic reaction. Endo means absorbed, taken in. So when heat is absorbed during a reaction, that reaction is known as endothermic reaction. In that case, plus heat is written on the left-hand side along with the reactants. If heat is evolved or given out during a reaction, it is known as exothermic reaction. Exo means out, given out. So heat given out, it's known as exothermic reaction. And in that case, plus heat is written on the right-hand side along with the products. Then conditions of reactions like heat, temperature, pressure, catalyst used, etc. are written above and below the arrow. So all the conditions required during the chemical reaction, they are mentioned either above or below. If the conditions are more, you can use both the space above and below the arrow. Let us recall the example of burning of magnesium ribbon in air. The equation which we had written was 2 mg plus O2 gives 2 MgO. Now this equation gives us the information that our reactants are magnesium and oxygen and our product is magnesium oxide. That is all it tells us. Now we can make this equation more informative by writing S next to Mg, telling us that magnesium is solid plus O2, oxygen is a gas. So either you can put this upward arrow or you can write G in bracket. Then on heating, so this reaction occurs only when magnesium is burnt in air. So on providing heat, we put the symbol of heat, or you can write BURN, burn, on the arrow. And magnesium oxide is a powdery ash, so it's solid, so you write S in bracket. So now this is a complete equation which gives us more information about the state of the reactants and the products and about the condition of the reaction. Similarly, the next example, calcium carbonate, it is solid, so S. On heating, this triangle stands for heat. You can even write HEAT in words, heat, instead of the triangle. On heating, calcium carbonate decomposes or breaks down into CaO, calcium oxide, which is a solid, plus carbon dioxide, which is a gas. So either it can be written as this or with an upward arrow like this. The third example, zinc, that is Zn, solid, plus dilute H2SO4. Dilute H2SO4 is an aqueous solution, that is water is added to it, so therefore it can also be written as H2SO4 AQ in bracket. Gives zinc sulfate, ZnSO4, it is a solution, so aqueous, plus hydrogen gas, again upward arrow or G in bracket. Now the last example, nitrogen, it is a gas, again here you can use the upward arrow instead of G, plus hydrogen gas. Now look at the conditions written on the arrow. Here Fe, it is a catalyst. A catalyst is a substance which speeds up the reaction without taking part in the reaction. So here iron or Fe acts as a catalyst, therefore it is written on the arrow. It is not participating in the reaction, and that is why it is not written on the left hand side. So a catalyst speeds up a reaction without participating in the reaction. The specific temperature for this reaction is mentioned here, 700 K. The specific pressure required for this reaction is mentioned here, 200 atmosphere. So the conditions of the reactions is written above and below the arrow. The products are NH3 or ammonia, which is a gas, plus heat. Now this plus heat is written on the right hand side along with the product. It means that this reaction is an exothermic reaction. Heat is given out during this reaction. So all these informations we get from this equation: the state of the reactants, the state of the product, the conditions of the reaction, and whether the reaction is exothermic or endothermic. Now you have an assignment. You need to translate the following chemical reactions into chemical equations. So 2 questions are given. Try to translate these chemical reactions into chemical equations. First one is, on passing carbon dioxide gas through lime water is calcium hydroxide solution, a white precipitate of calcium carbonate is formed along with water. Second is, when zinc is added to a solution of iron 2 sulfate, a colorless solution of zinc sulfate is formed along with deposits of iron. So first of all, you will write the word equation and then you will convert that word equation into chemical equation. So happy learning. Bye bye. God bless and take care.